In this video, I'd like to talk about what makes a value a percent, and then more specifically, how to convert between percents, decimals, and fractions, and keeping all these forms equivalent. So the first thing we want to notice is, well, what does the word percent mean? And percent literally means parts out of 100. So when I say 70%, I'm literally saying I have, out of 100 pieces total, I have 70 of them. So I have a couple of examples here. When I say the word 20%, what I'm really saying is that out of 100, I have 20 total. We can write this as a fraction, where we're literally saying out of the total parts 100, I have a total of 20 of them, which we notice as a decimal simply reduces down to 0.2. So three different equivalent forms. 20% is the same as the fraction 20 out of 100, which is the same as the decimal 0.2. Now, one thing we want to notice about converting to decimals, because we're really just dividing 20% by 100, I notice that whenever I divide by 100, I'm essentially just moving the decimal place to the left 2, which we notice gives me this decimal 0.2. We'll talk about this more later. So now, continuing here, if I talk about 57%, I notice that 57% again means I have out of 100, 57 total. So I can write this as a fraction out of the 100 total on the bottom. I have 57 of them, which reduces to the decimal 0.57. So first, I want to talk about converting percents either to fractions or to a decimal. And they both rely on the fact about what the definition of a percent is. Percent literally means out of a 100. So what we're going to do is change the percent to a fraction over 100. So literally making it that value out of 100. Then we simply need to simplify the fraction, and then there's our equivalent fraction. Now to convert to a decimal, as we saw before, since percent literally means I'm relating it to parts out of 100, I'm essentially dividing by 100, which means that we're really just moving the decimal places 2 points to the left to find the equivalent decimal. So again, for both methods, what we're really doing to make a percent in terms of a decimal or a fraction, I'm really just dividing by 100 and then simplifying. So let's take a look at a few examples. In this first example, I'm asked to change 39% both to a fraction and to a decimal. So first, if we make it to a fraction, I'm going to apply the definition of what percent means, and it literally means out of 100. And we can even write this out. 39% literally means 39 out of 100. So in fractional form, I'm literally going to write this as the fraction 39 over 100. And the only thing I need to do before I call this my simplified fraction form is to look for just that. Is there any way I can simplify? So I'm looking at both numbers, 39 and 100, and saying, is there anything that divides both of these evenly? Now, 39 is only divisible by 3, 13, and 39. And since none of these divide 100, it actually turns out that my simplified fraction form is simply just 39 out of 100. Now to make this a decimal, I noticed really that dividing 39 by 100, we talked about how really all this is doing is moving the decimal place 2 points to the left. Or in other words, to write 39 hundredths as a decimal, I'm just taking the decimal point, moving it to the left by 2, and then I see that my equivalent decimal now is simply 0.39 as my resulting decimal. So similar example, I have 157.4%. This is literally saying 157.4 out of 100, which as a decimal means 157.4 over 100. There's my fractional form. Now the tricky part here is that I have a decimal inside of a fraction. I'd really like to try to simplify this so that it is no longer inside of a decimal. I want this just to be an integer divided by an integer. Or in other words, I need to simplify this fraction a little bit. So what I'd like to do first is get rid of this decimal point 4. And just as dividing by 100 moved the decimal point 2 points to the left, it actually turns out that if I multiply by 10, this just moves the decimal point 1 place to the right. Or in other words, this will give me 1,574. So that's 1,574 over 1,000. You might say, well, that looks like I made it more complicated. But the advantage is that now we don't have that decimal of 0.4. And now I can just simplify this like I would any other fraction. So I'm just going to start dividing out values that I know divide both 1,574 and 1,000. And it's perfectly acceptable here that you might want to dig out a calculator in order to divide these. But I can also just start with simple values that I know work. For instance, I can divide both these values by 2, or in other words, I can divide both the top and the bottom by 2. And notice that I'm really just dividing by 2 over 2, which is 1. I notice that this would give me on the bottom 500. And on the top, dividing this 1,500 is divided by 2 is 750. 74 divided by 2 is 37. So that looks like that'll be 787. And at this point, I can try and find more common factors, but it actually turns out that 787 and 500 don't share any other common factors. Kind of a tricky problem, but this will be our simplified fraction, 787 over 500. So it's okay that this didn't simplify down very nicely. The important thing is that I do have this simplified down to an equivalent fraction. Now for the decimal, again, the nice thing is that dividing 157.4 by 100, in terms of a decimal, literally just means I'm moving this decimal point 2 spots to the left, which is pretty easy. You can see I did that up there on the original number. So if I move it to the left by 2, my new decimal is now 1.574. One more example. I now want to convert 0.9% to both a fraction and a decimal. So again, first of all, converting to a fraction, percent literally means I have 0.9 out of 100. So how many out of 100 is that? I want to simplify this fraction now. And again, the problem is that I have this 0.9. I can get rid of that again by multiplying both the top and the bottom by 10, essentially moving the decimal place to the right by 1, and this would then give me 9 over 1,000. Now I notice that 9 only is divisible by 1, 3, and 9. 3 and 9 do not divide 1,000, so this would actually be my simplified fraction, 9 over 1,000. Now as the decimal, again, if I divide by 100, this literally means that I'm moving the decimal point 2 points to the left. So if I go back up here to the 0.9 and we look at moving that decimal place 2 points to the left, I can see here that I move it once and twice. I actually have an extra spot here that I have to fill in with a 0. So my new number actually becomes 0.009 for our decimal. So our new decimal is 0.009. And again, just the result of moving this over and kind of tying this back to our fraction, I notice that 9 thousandths, if I count the places, the first here is the tenths place, the hundredths place, and then the 9 here is the thousandths place. This is literally saying 9 thousandths, just like the fraction is saying 9 out of 1,000. So now if we talk about the other way, if I'm now going to convert fraction and decimals back to percents, the opposite of what we just did, since we're doing the opposite of changing percents to fractions and decimals, it makes sense that we're going to have to do the opposite of what we had to do to change percents to fractions and decimals. And that is exactly what we're going to do. If I need to take a fraction or decimal and take it back to a percent, instead of dividing by 100, we notice that we're actually going to multiply both the decimal or the fraction by 100, and then we simply need to simplify the resulting value to a decimal form of whatever that percent is. So in our first problem, I'm asked to convert the decimal 0.47 to a percent. So again, 0.47 is literally saying, okay, out of 100, what does 0.47 mean? How many parts out of 100 is that? Well, it turns out, again, to make a decimal in terms of a percent, I simply need to take 0.47, and now we're going to multiply it or scale it up by 100. Now remember, multiplying by 100 is essentially saying that I'm moving this decimal point, 0.47. Now that we're multiplying it, we're moving it to the right. So I actually see that this simplifies down to simply 47. And since we're now talking about percents, that would be 47%. Now just a way of checking this, remember what percent means. 47% literally means that I have 47 out of 100. So I want to keep this in mind. Well, does 47 out of 100 really represent 0.47? And it's true. If I write this as the fractional form, 47 over 100, I recognize that this is really the same thing as this decimal 0.47, which we started with, because this is literally saying I have 47 out of the hundreds place, or in other words, dividing by 100, I'm moving that decimal point 2 points to the left. So all these values are now connected. So now if I want to convert the decimal 1.327 to a percent, I'm going to again take 1.327. I'm going to multiply by 100, which essentially means I'm taking this decimal, moving it 2 points to the right now because we're multiplying. And what I see is that this is going to then give me 132.7%. One more problem. I'm asked to convert the decimal 0.0083 to a percent. Now this is a very small value, so I'm expecting a very small percent. Let's see if that's true. Because I'm converting a decimal to percent, I'm going to multiply by 100. So if I multiply by 100, this is really telling me to move that decimal point 2 places to the right. But notice that this actually only gives me 0.83. See how that point is still to the left of the 83%. So again, 0.0083 is a very small number, and it's still a very small percent. Less than 1 out of the 100. This makes sense. If I go back to my decimal, I actually notice that I don't have anything in the tenths or the hundreds places, so it makes sense that I have less than 1 out of every 100. So finally, if we now talk about converting a fraction to a percent, even though we're talking about fractions, I'm still doing the same procedure. So I'm still going to convert something to a percent by multiplying by 100, or in this case, since I'm multiplying a fraction, I can imagine multiplying by 100 over 1. Now this will translate out into 500 out of 8, or over 8. And now since I'd like this as a percent, I'd just like to reduce this down to some decimal. So I can literally on a calculator now just do exactly what this fraction tells us, 500 divided by 8. And I see that this actually then gives me 62.5, which means my answer is 62.5%. Good. So essentially, if we think back to the proportions we're talking about here, what this is really saying is that if I have 5 out of 8 in terms of a fraction, this is the same thing as saying that I have 62.5 out of 100. So in other words, it's saying that this is a true proportion. 5 out of 8, the same thing as saying 62.5 out of 100. That's what percent means. Let's try another problem. So now if I convert the fraction 2 1/4 to a percent, really I just have one preliminary step here. The first thing I'd like to do is make this a mixed number. So I need to give these a common denominator. I can change the 2 into an 8 over 4. So really what we're talking about here is 8 over 4 plus 1 over 4. So the fraction, or the improper version of it anyway, that we're dealing with is actually the fraction 9 out of 4. Now that I have an improper fraction, I can change this to a percent just like we always would by multiplying by 100 and then simplifying. So if I multiply by 100, I see that I'm going to end up getting 900 over 4. And now all I need to do is simplify this to a decimal, and I can use a calculator as an aid here. So if I do 900 divided by 4, I find that I end up getting 225, or in other words, 225%. And again, if we think about the meaning of this, what this is saying is that if I start out with 9 out of 4, this is the same thing as saying that in terms of percent, I have 225 out of every 100. Now this is a little weird, because we're almost saying I have more than the possible number of totals, but it is possible many times in different examples to actually have more than what is considered a whole. Think of, for instance, I have 2.5 pizzas. You have 2.5 wholes, which is why you'd actually have 250% of one pizza. So final problem, again I want to convert this fraction to a percent. It's already an improper fraction, so I can simply multiply by 100. And we actually recognize here that I don't even need a calculator to aid me. Since I'm dividing by 100 here and multiplying by 100 in the top, these are actually inverse operations, and I can recognize that these actually just divide to 1. So this is actually just going to simplify down and become 17%. Now why does this make sense? Well, quite simply, 17% means 17 out of 100, and if I go back to my original equation, or original expression, that's exactly what this says. I already had 17 out of 100. It's already following the definition of a percent, which is exactly why our final value is 17%. So at this point I have some problems for you to try on your own. Take a look at those over the weekend, and we'll check back in class on Monday.